Hi friends. So we'll look at the kind of problems which says show that LHS is equal to RHS. Okay. So basically what we are saying is prove LHS is equal to RHS type of questions. Now very important note, when doing problems which say prove LHS is equal to RHS, please convert all terms whether it is in LHS or RHS to sine or cos. This will make it easy to prove LHS is equal to RHS. Okay, all the terms you convert them to sine or cos, that will make it easy to show the proof. Let's take an example. Okay, prove cot A minus cos A divided by cot A plus cos A is equal to cosecant A minus 1 divided by cosecant A plus 1. Okay, like I suggested here, what I will do is I will take LHS, that is the left hand side of the equal to sign, and I will convert each term in as per sine and cos. Okay, what is cot A? Cot A, if you remember, is cos A by sine A. Okay, cos A I will put it as is. Okay, and even in the denominator cot A I will replace by cos A divided by sine A, and I will put cos A as is. So LHS is this. Okay, now what we can do is, see, cos A is here also, cos A is here also, we can take it common. Okay, and put a bracket, and if you take out cos A from here, 1 by sin A is left. Okay, and minus 1 is left. Why? Because cos A and cos A we have taken it out common. Similarly, from denominator also, cos A I am taking out common. So cos A, when you take out common, you will get 1 by sin A plus 1. Okay, so cos A has been taken out common. Since the cos A is in both numerator and denominator, we have cancelled it. Okay, and this has become 1 minus 1 divided by sin A minus 1 and 1 divided by sin A plus 1. Okay, let us call this equation 1. Now take the RHS. As I said, in RHS also, all the terms you write in terms of sine and cos. So what is cosecant A? Cosecant A, as you know, is 1 upon sine, right? So instead of cosecant A, we have substituted 1 by sin A here, minus 1 is as is. And similarly, denominator also 1 divided by sin A, we have replaced cosecant A as 1 by sin A plus 1, we have done this. And if you look at equation 1 and 2, both are same. Here also 1 by sin A minus 1 divided by 1 by sin A plus 1. Here also 1 minus sin A minus 1 divided by 1 divided by sin A plus 1. Since these two are equal, LHS is RHS. Because LHS also got simplified to this, RHS also got simplified to this. Since these two are equal, we have proved that this is equal to this. Okay, please remember this technique, it is very important. Write all the terms in terms of sine and cos, and it will be easy to prove that LHS equal to RHS. Okay, now let's look at this problem. They are saying that 9 secant squared A minus 9 tan squared A is equal to what? Okay, so for that, what we will do is, since 9 is common in both of these terms, we will take it out. We will say 9 into secant squared A minus tan squared A, right? And what do we know about these two guys? See, remember, you have studied trigonometric identities, which you should remember. 1 plus tan squared A is equal to secant squared A, right? So if I take the tan squared A to the other side, okay, what will I get? Secant squared A minus tan squared A equal to 1, right? So secant squared A minus tan squared A equal to 1. So substituting for that, we get 9 into 1 equal to 9. Alright? So you have to remember this trigonometric identities to solve such problems. Next problem. They say 1 plus tan theta plus secant theta into 1 plus cot theta minus cosecant theta is equal to what? Okay. So again, remember, replace everything as sine and cos. So I will say this is 1 plus tan theta is nothing but sine theta by cos theta. Secant theta is 1 by cos theta. Okay. And here we have again multiplied by inside the bracket 1 plus cot theta is cos theta by sin theta minus cosecant theta, as you know, is 1 upon sin theta. So we have replaced all terms using sine and cos. Okay. Now look at this term inside the bracket. There is cos theta here, but no cos theta in the denominator under the 1. Okay. So LCM is cos theta. So denominator becomes cos theta, means numerator also has to be multiplied by cos theta. So here you get cos theta, and in the bracket cos theta plus sin theta minus 1. Okay. Similarly, here you have sin theta in the denominator, here also okay sin theta, but 1 doesn't have sin theta in the denominator. So to take we have to take the LCM, and you'll get sine theta, and numerator also will become sine theta. So we get sine theta plus cos theta minus 1 here. Okay. Now look at this. We have cos theta plus sine theta that we can put in the bracket and say plus 1. Here we also have cos theta plus sine theta that we can put in the brackets and say minus 1. And denominator cos theta, denominator sine theta, they are as is. Now this looks like a plus b into a minus b, which is a squared minus b squared, where a is cos theta plus sine theta and b is 1, which is nothing but a squared minus b squared. So we are getting cos theta plus sine theta whole squared minus 1 squared is 1, divided by cos theta into sine theta. Okay. So what is this now? This looks like a plus b whole squared, right? What is a plus b whole squared? From your previous class, we know that a plus b whole squared is a squared plus b squared plus 2ab, correct? So here we get cos squared theta plus sine squared theta plus 2 sine theta cos theta. Applying this formula, minus 1 divided by cos theta sine theta. Okay. But note that cos squared theta plus sine squared theta is 1. That is the trigonometric identity. Okay. So these two terms can be replaced by 1. This 2 sine theta cos theta will remain as is. This minus 1 will remain as is, and this cos theta sine theta will remain as is. Now this plus 1 and minus 1 will get cancelled, leaving us with 2 sine theta cos theta divided by cos theta sine theta. Finally, we will end up getting 2. Okay. So that is the value of this equation. Okay. So again, the trick of replacing everything with cos theta and sine theta was used along with these formulae. A plus b into a minus b is equal to a squared minus b squared. A plus b whole squared is equal to a squared plus b squared plus 2ab. And cos squared theta plus sine squared theta is 1. Okay. So this is the problem. Okay. Now let's look at the next problem. Next problem, they are saying secant a plus tan a into 1 minus sine a equal to what? Okay. Is it secant a? Is it sine a? Is it cosecant a? Or is it cos a? Which of these? Okay. So LHS, again, remember the same technique. I am replacing every term by sine and cos. Secant a is 1 by cos a. What is tan a? It is sine a by cos a. They are inside the bracket, and 1 minus sine a, I am writing it as is. Okay. Now look at this. Cos a and cos a in the denominator. So it is okay to add these up. So we get 1 plus sine a divided by cos a, and this bracket remains as is 1 minus sine a. Now remember, this is a plus b into a minus b. What do you get? A squared minus b squared. So we are getting 1 minus sine squared a divided by cos a. But remember, cos squared a plus sine squared a equal to 1. So if you take this sine squared a to the other side, you will get cos squared a, right? So 1 minus sine squared a is cos squared a divided by cos a. Okay. So cos a and squared will cancel, and only a cos a remains. Because cos squared a is nothing but cos a into cos a. That's why there is square there, right? So one cos a will cancel the square, but the other cos a will remain. So option D is the correct option in this case. Okay. Then another problem, they are asking 1 plus tan squared a plus 1 plus cot squared a is equal to what? Is it secant squared a? Is it minus 1? Is it cot squared a? Or is it tan squared a? What is it? They are asking. So we remember our trigonometric identities. 1 plus tan squared a is equal to secant squared a, and 1 plus cot squared a is equal to cosecant squared a. So remember these two identities. Okay. Using these two identities, we substitute for 1 by tan squared a as secant squared a, and 1 by cot squared a is cosecant squared a. Now what is secant a? It is nothing by 1 by cos, isn't it? And there is squared here, so it is 1 by cos squared a. Similarly, cosecant squared is nothing but 1 by sine squared a, right? And these are fractions, and there is a division here, so this remains as is, but the fraction in the denominator is inverted. So sine squared a goes up, 1 comes down. Okay, so this can be written as sine a by cos a whole squared. Why? Because sine squared a is here, cos squared a is here, so that is nothing but sine a by cos a whole squared. But what is sine a by cos a? It is nothing but tan a. So tan squared a is the answer. So option D is the correct option here. Okay. So coming to the next problem, they are saying prove that cosecant theta minus cot theta is equal to 1 minus cos theta divided by 1 plus cos theta. Again, apply the same technique. Whenever you have to prove LHS is equal to RHS, replace all the terms by sine and cos. So cosecant theta, as we know, is 1 upon sine theta. Cot theta, as we know, is cos squared theta, cos theta by sine theta, right? So I have replaced cosecant theta by 1 by sin theta and cot theta by cos theta by sin theta. Note that these two denominators are the same, so you can subtract directly, and note that there is a squared for both the numerator and denominator. So we get 1 minus cos squared theta whole squared, right? 1 minus cos theta whole squared divided by sin squared theta. Okay. Again, what is this a plus this is what is this simplified to? This simplifies to, see, this is a minus b whole squared. Okay, a minus b whole squared is equal to a minus b into a minus b. So we write this as 1 minus cos theta into 1 minus cos theta. But what is sin squared theta? Remember, cos squared theta minus plus sin squared theta is 1. So we can write sin squared theta as 1 minus cos squared theta. And what does this look like? This looks like a plus b into a minus b, right? A squared minus b squared is equal to a plus b into a minus b. So 1 minus cos squared theta, we have written it as 1 plus cos theta in the denominator into 1 minus cos theta. Okay, so what happens? Here 1 minus cos theta, 1 minus cos theta get cancelled because of the numerator and denominator. And what remains is 1 minus cos theta divided by 1 plus cos theta, which is nothing but the right hand side. So we have proved left hand side equal to right hand side. Okay, so let's look at the next problem. Cos A divided by 1 minus 1 plus sin A plus 1 plus sin A divided by cos A, prove that it is equal to 2 secant A. Okay, so if you take the LHS to add these two guys, these denominators are different. 1 plus sin A is different, cos A is different, isn't it? So we have to take a LCM. What is the LCM? LCM is nothing but 1 plus sin A into cos A, right? If you multiply these two terms, that is the LCM. So if the denominator has to be this guy has to be multiplied both numerator and denominator by cos A. So that becomes cos squared A. And if this denominator has to be 1 plus sin A into cos A, both these two guys have to be multiplied by 1 plus sin A. So 1 plus sin A into 1 plus sin A, 1 plus sin A squared cos A. Okay. So here you can see that once we add, we'll get cos squared A, and this is a plus b whole squared, right? A squared plus b squared plus 2ab. So we get cos squared plus 1, that is a squared. B squared is sin squared A, plus 2ab is 2 sin A, because b is just 1, isn't it? So, and we also note that cos squared A plus sin squared A is 1. Okay, so this one and this one together will give you 2. Okay, and 2 sin A is written as is. Okay, and the denominator 1 sin A cos A remains as is. Okay, if you take this 2 common outside, you will get 2 into 1 plus sin A divided by 1 plus sin A, and cos A is there. This 1 plus sin A and 1 plus sin A gets cancelled, and cos A, if you take it above, it will become secant A. So you get 2 secant A, which is the right hand side. So again we have proved LHS is equal to RHS.